Hi there, and then welcome to the Hub Beyond Numbers. We are still on probability. We are looking at the rules of probability. We've looked at addition or and then now we are looking at or. When we talk of the or, what do we mean? Now, by the end of this video, you should be able to understand the meaning of what or means in probability. You should be able to differentiate between mutually exclusive and then non-mutually exclusive events, and then also apply the rule of or, and also solve some questions as well. Now, let's go straight to it. So, or refers to the occurrence of at least one of two events. You see, so you have two events, right? The occurrence of at least one of them. So it's either just one of them, that is A or B, or both of them. So at least one of them should be present, right? The probability of A or B is usually written as what we see here on our board. That is, so we have the probability of A or B. That is what we see here. Yes, A into bracket A union B. So the union sign there is what we term as the or. This means either A, event A, this over here, event B, or both of them. So either one of them, that is A or B, or both of them. That is what or means in this case. Alright. So there are two cases we need to know whenever we are talking of or want to use or. There is the mutually exclusive, which we will be talking about now. When we say two events are mutually exclusive, then it means they cannot happen at the same time. They can never happen at the same time. Is it possible that on a die, you just roll a die, right? And you'd get two numbers. That is, you either get 1 and 2 at the same time on just one row. That doesn't happen. So such events are impossible to occur at the same time. Hence, if you want to find their probabilities, we say they are mutually exclusive, right? Hence, if you want A or B, when two events are mutually exclusive, then we just add the individual probabilities of both events. Easy. So we have this event over here, and we have this event also over here. Now we want the probability of A or B occurring. So using this formula here, we say the probability of A or B occurring is simply the sum of their individual probabilities. The probability of A or B occurring is simply what? The sum of their individual probabilities. Alright? Okay. So with that in mind, let's look at another one which is called non-mutually exclusive. Now, events are not mutually exclusive or non-mutually exclusive if they can occur together. If they can do what? They can occur together. If you look at non-mutually exclusive events, what we mean here is the events are not mutually exclusive. Hence, they can occur together. Let's look at the card, for instance. So let me zoom in here. Okay, I'm trying to zoom in here so that we see these cards I have over here. Now, as you can see, we have the spade, the diamond, the hat, and then the club. Well, I think this is the club, and then the diamond, the hat, and then the spade. If we are looking at them carefully, we have our jack, and then the queen, and then the king. Now, if I want to pick, first of all, the diamond. These are the diamonds. And then now I also want to pick a queen. It is possible that whilst picking the diamonds, I'll pick a queen as well. The reason being that we have a queen which is also a diamond. You see, so these two events can occur together. Hence, they are not mutually exclusive. If events can occur together, that is when we say they are what? Not mutually exclusive. I hope that makes sense. So, if we are trying to look for the probability of non-mutually exclusive events using the additive rule of probability, it says we should do our normal addition as we do for mutually exclusive, but then we should make sure at the end of the day we will take out their intersection so that there will not be double additions. We have this here being probability of A, this here also being probability of B. There is a portion where they intersect, you see, so they can occur together. Now, if we separate these two probabilities, probability of A and then B, if they are separated, you see this portion we have over here. So, this portion we have over here. This portion here. It is the same as the portion we have over here. But if we stack them on each other, we are getting two of those portions. You see, so what the rule is saying is, if that is the case and we don't want to do a double addition, then let's just claim here, right? Let's take that out of the way, so that if it happens that we stack them together, this one here is just going to fit perfectly into the other one. So let me try and see if I can do something like that over here. I'm trying to fit this one. So as you can see, easy, that has, we are going to get this, you see, rather than going to get a double. So that is how we work for non-mutually exclusive events. We'll be solving some examples so you'll be able to apply these formulas. Once again, we've looked at two formulas. The first one for mutually exclusives, right, which says you should just add the probabilities and then go your way. But then the second one is for non-mutually exclusive. Because they occur together, we want to remove that double portion of their occurrence so that there wouldn't be a double addition. I have some few questions here I would like us to solve. The first one says a die is rolled. A die is rolled. And what is the probability of getting a 3 or a 5? A die is rolled, and what is the probability of getting a 3 or a 5? I want to assume that as at now you understand the basic probabilities, and you can calculate the probability of getting a 3 and then the probability of getting a 5. Hence, we wouldn't waste time. If this is your first time visiting this channel, and then on this playlist we have 2 or 3 videos explaining how to solve for basic probabilities. You can visit that and come back here so you come and then follow along. So in solving for this, we first of all need the probability of getting a 3. So the probability of getting a 3 is definitely going to be 1 over 6. That is the number of what events. In a die, there are only 1 of the 3s. And how many outputs do we have in total? We have 6 of them. That is why probability of getting a 3 becomes what? 1 out of 6. And the same way, the probability of getting a 5 is then going to be what? 1 out of 6 as well. So now that we have the individual probabilities of our events in question, what do? It says, what is the probability of getting 3 or 5? What is the probability? of getting 3 or 5. Talking of or, we know that this kind of events are mutually exclusive, meaning they cannot occur together. Hence, using our formula for mutually exclusive, it says the probability of A union B is equal to the probability of A plus probability of B. Listen, so substituting, we have our 1 over 6 plus 1 over 6. And we know 1 over 6 plus 1 over 6 gives us a what? A 2 over 6. We can do our further simplification where 2 divides itself once and then into 6. How many times? Thrice. Hence, we have what? 1 over 3. So the probability of getting a 3 and a 5 then becomes what? 1 over 3. Let's look at our next question. Our next question says, a card is drawn from a standard deck of 52 cards. What is the probability of drawing a king or a spade? What is the probability of drawing a king or a spade? So, let me zoom once again and then we consider these cards. So, okay. So this we have over here. We are talking of spades, right? And for a standard deck, we have 52 cards. 1, 2. So yeah, there are 52 of these cards. All right. With this 52, it says what is the probability of drawing a king? The probability of drawing a king. So probability of drawing a king, we have 1, 2, 3, 4. You see? So the probability of drawing a king, let me write that here. Probability of drawing a king is then going to be what? 1, 2, 3, 4. 4 out of the total number of what cards we have, which is 52. Alright. Then we come to our next item, which is what is the probability of drawing a king or a spade? So probability of drawing a spade then becomes, so we know there are 13 of these spades. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the probability of drawing a spade is also 13 over what? 52. Now, we should know that this is a mutually exclusive event. The reason being that there's a likelihood of we getting a king which is also a spade. Right? So they are mutually exclusive. They can both occur at the same time. Easy? And that is what we say P, king, and then intersection what? S. That is giving us, so if you look at the spades, how many kings do we have in there? We have 1. So we have 1 out of the 52 number of cards. You have a total. Alright? 1 out of the 52 number of cards we have in total. I can now zoom out so we solve our question. So as at now, we have all our parameters. We do have all parameters. Alright? But before we proceed, let me just go over this again. A card is drawn from a standard deck of 52 cards. What is the probability of drawing a king or a spade? We want a king or a spade. You see? And we agree to the fact that due to the nature of the cards, there are some kings that are spades, or there are some spades that are kings. Right? Hence, they occur together. They are not mutually exclusive. They are non-mutually exclusive. And we are talking of or has to do with addition. Alright? So we started by looking for the probability of we obtaining a king. That is what we had over here. Then the probability of we obtaining a spade. And since they are both going to occur together, we need this as well. The probability of they occurring together. Alright? We know the formula we are going to use. The probability of king or speed is equal to the probability of obtaining a kin plus the probability of obtaining a speed, then minus the intersection. Right? So substituting our values, we are going to get probability of kin. We said that was what? 4 over 52. So 4 all over 52 plus probability of obtaining a speed, which is what? 13 over 52 minus the probability of obtaining what? Kin and speed all occurring together. Now this is just a simple addition. Since the denominators are all the same, we can say we have 4 plus 13, which gives us 17, minus a 1, which is what? 16. So we have 16 over what? 52. And we can simplify it. We can simplify it further to give us 4. Yeah, I think 4 divides 16. So 4 divides 16, giving us 4. Then into 52, we have 13. So we simplify it further to give us a 4 out of 13. Right? Yeah, so we've come a very long way looking at what? Probabilities. Let's look at our very last question here, which says, in a group of 50 students, 20 study maths, 15 study physics, 5 study both maths and physics. What is the probability that a randomly selected student studies mathematics or physics? Let me quickly draw a Venn diagram to illustrate that, then we come back to solving it. Well, you don't actually need to draw a Venn diagram, but just to get a graphical presentation of what we are doing. That is why I want to draw it. Okay, so this is just a quick one. Based on the data we have, all right, this is the representation. So we have 50 people as the universal set, the total number of students, and 20 studying mathematics. This is our 20 here that study mathematics. 15 studying physics. This is 15 that study physics. 5 study both. So starting from the inside, we put our 5 here for intersection of both mathematics and physics. And if this whole circle here is supposed to give us 20, we already have 5 here, then this is supposed to be 15, right? The same way, this whole circle here is supposed to give us 15, whereas we have 5 here already. Then the remaining here should be what? 10, right? Now, if we are to add everything here, we are supposed to get 50. But if you look at it carefully, 15 plus 5 plus 10 gives us, that is 30. But then the universal set is supposed to be 50. Hence they are complements. That is why you see this 20 over here. They do not they don't study maths nor physics. Now to our question. It says, what is the probability that a randomly selected student studies maths or physics? If you're able to draw this, then from your diagram, maths or physics is just going to be this portion over here. This portion over here. We know we need a number of, or let's say the probability, let me use a white, the probability of people who will study maths. That will be the number of students studying maths, 20, over the total number of students, which is what? 50. Then we want the probability. Probability, you are not supposed to bring this n here. So that is probability of maths. Then probability of physics. That is, we look at the people studying physics, 15. So 15 all over what? The 50. Alright. Then the probability that a student is studying both mathematics and physics, that is 5. So coming back to our formula, where there is an intersection, So we say the probability of obtaining a student, which that is, what is the probability that a student selected at random studies, maths or physics? So that's going to be maths union physics, right? And we know the formula to be what? Probability of maths plus the probability of physics, then minus their intersection, because this is a what? This one is non-mutually exclusive, right? So they both occur together. So minus probability of M intersection P. Simplifying further or substituting, we have 20 over 50 plus 15 over 50, then minus 5 over what? 50. All right, which gives us 20 plus 15 minus 5, that is 30 over 50. And when we simplify, we can rewrite it as what? 3 over 5, right? This is using the what do you call it? The formula. But then assuming we just wanted to look at it straight away, based on our Venn diagram. You see this shape I've done over here? That is the region we are focused, the mass or physics. This is the red region over here. All right. So this red region over here, we add 5 to 15, giving us what? 20 plus 10. That is 30. We straight away get our what? 30 over 50. So there are so many ways of solving, but make sure you know what you are doing. If it's either mutually exclusive or not, you should know. And most of the times, if it's a Venn diagram problem, you can choose to draw a Venn diagram. That is if you are good at it. And then identify the portion that is favorable to your question, and then you solve. Right? So these are some questions you can try on your own. As always, it's good to try these type of questions so that you become familiar with it. This is the Maths Hub. Thank you for staying tuned, and there will be more videos explaining more concepts in probability. If this is your first time, you can choose to subscribe so that anytime I release a video, you'll be notified as well. So stay blessed. Bye.